Hi guys, welcome to Unit 6, Lesson 3, Surface Area of Cubes and Rectangular Prisms. Alright, so first off, surface area is the measure of the total area of the surface of a three-dimensional shape. So think if you were wrapping a present, right? It's like if you were to not overlap any of the paper, right, how much paper would you use? That would be like surface area, okay? There's two different types of surface area that we're going to be looking at today. First is for rectangular prisms. All right, the surface area, it's equal to 2 times the width times the length, plus 2 times the width times the height, plus 2 times the length times the height. Now, it sounds like there's a lot going on. When we get into our examples, hopefully that will make more sense because we'll be using that formula, and I will show you what it means to be, like, why do we multiply by 2, stuff like that, okay? And then a very particular type of rectangular prism is called a cube, okay? Technically, it's still a rectangular prism, but it's special because every single side is identical, right? They're all squares of the exact same size. So that's why we can take, like, the side times the side to get the area of one side, and then multiply it by 6 to cover all of them. But again, we'll talk about that in our examples. So for our first example here, this is number 4 from your practice. It says, what is the surface area of the rectangular prism? Now we are given 3 different values, okay? So, and to some extent it doesn't really matter what we label each of them as, but I'm going to say like this is maybe the length of the box, so I'm going to label that as L. I usually use a cursive L so that way it doesn't look like a 1. This 9, that would be like the width of the box. Right? Length times width, those are always like perpendicular to each other. And then the height of the box is 3. Now, I tried to copy the drawing as best as I could from number 4, but you'll notice, like, compared to the height, this length right here does not look like 9, but we're just going to go with it, okay? So the formula that we're going to use, now, we have 2 of every type of side, okay? And that's why, with the formula, we're multiplying each area by 2. So, like, if I just focus on the bottom, right, like the bottom of this rectangular prism right there, to find the area of it, I would multiply the length times the width, right, or width times length, same thing, right? But that is also identical to the top. Right? The bottom of the box and the top of the box are the same, right? So that's why we multiply it by 2, okay? Same thing. I'm just going to color code this whole thing, so hopefully we can make sense of it. The width times the height. Well, here's my width. Here's my height, right? So that's like the right side of the box, which is also identical to the left side of the box. So up here in my formula, that would be like those guys. Okay, these are my green ones. Okay, and then the last one, let me see, what would be a good color? Maybe I'll use this like pink kind of color. These ones here, length times height, that would be, well, here's my length and here's my height. That's like the front of the box. That's this right here. So that did not go as well as I wanted it to, but it's also identical to the back of the box, right? So we have 2 of each, and so that's why we multiply by 2 in our formula. So using that formula, I'm going to rewrite it down here. I've got 2 times the width times the length, or length times width, plus 2 times the width times the height, plus 2 times the length times the height. Okay? And then we just have to plug in our values. So we've got 2 times, and the width times length would be 9 times 10, plus 2 times 9 times 3, that's my width and my height, plus 2 times length and the height, so 10 times 3. Okay, then using the order of operations, right? We got to do what's inside the parentheses first. So that's these guys. So this would come down to 2 times 90. Oh, not 9 times 90. Good thing I caught that. That would have thrown my answer way off. 2 times 90, that sounds better, plus 2 times 27 plus 2 times 30. Okay, so parentheses are gone. Right now, these parentheses, that's just how I'm showing my multiplication, right? So there's no exponents. So next we would take care of multiplication, and then we're going to take care of the addition. So let's see, 2 times 90 is 180. 2 times 27, ooh, what's that? That's 54. Plus 2 times 30, oops, which is 60. And then we're just going to add them together. To me, personally, these look easier to add. If I add those together, I get 240 plus 54 gives me 294. And these were inches. And whenever we're talking about area, we should always have our units be squared. So the surface area, like if we were to wrap that box perfectly with paper, we would need 294 square inches of paper. That's what that's telling us. Okay? So we have to break it up, but it makes it a lot easier. All right, number 2. This is number 5 from your practice. What is the missing width of a rectangular prism with a length of 6 centimeters, height of 4 centimeters, and a surface area of 188 centimeters squared? So this time, we're kind of working backwards. We already know the area. We're searching for the width. But we can plug in everything else that we know and then solve from there. So let's see here. Surface area, we were told, is 188. And we've got 2 times, and we don't know what the width is equal to, but we do know the length is 6 plus 2. We don't know the width, but we do know the height of 4 plus 2 times 4 times 6. Okay? So with that, we only have one variable, which right now I know it looks like we have 2, but we can combine them after we take care of a couple things. Okay? So I'm going to rewrite this so it's like a little bit easier for us to see. We can rewrite this as 2 times 6w plus 2 times 4w plus 2, and then we can take care of this. 4 times 6 is 24. Okay, again, we'll rewrite it. 188. If I have 6w, but I have 2 groups of that, I have 12 w's. Plus, and then 2 times 4 is 8, so we have 8 w's. And then 2 times 24 is 48. Okay? I can combine like terms, which in this case, if I have 12 w's plus 8 more, then I have 20 w's plus 48. And now we're just down to a 2-step equation where we can solve for w. I'm going to subtract 48 from both sides. That's going to give me 140 equals 20w. Divide by 20, divide by 20. Those will cancel, and I'll have to move over here. So we're left with, let's see, 140 divided by 20 would be 7. So w equals 7. We were talking about centimeters, so that would be our width. Okay? So use the information that you know to figure out what you don't know. All right, number 4 on your quick check. This is our last one. This is a cube. I figured I should do one example as a cube. So it says, what is the surface area? Well, from the first page of the notes, we had surface area is equal to 6s squared. And you're probably like, where did the s squared come from? What does that mean? And the s is just standing for side length. If this is a cube, all of the sides, or all of those edges, are going to be equal to the same thing. So if this is equal to 1.5, that means this right here is equal to 1.5 meters as well, right? And so we're multiplying this number by itself, or we're squaring it, okay? And then we have 6 identical faces, right? We have the front, we have the back, we have the right, the left, top, and bottom. 6 total that are identical. So in this case, we'd have 6 times 1.5 squared. Now, using my calculator, 1.5 times 1.5, that's this part, right? 1.5 squared. And I could write that out for you if you want, just as a reminder. This is equal to 1.5 times 1.5. Well, that's 6 times 2.25. And then times 6 gives us 13.5. We were talking about meters, so this would be meters squared. So the cubes are nice because they're a little simpler. There's less to do and less to keep organized. Okay? So I hope that helps, and as always, if you need more support, let me know. Otherwise, have an awesome day.